Well, howdy, everybody. And this is iChem, and we're discussing thermochemistry, right? And the in our last lecture, we really focused on delta H, right? Delta H, heat of reaction, heat of formation, and we focused on this idea of delta HF prime. And we said, hey, what is that? That is my heat of formation or enthalpy of formation. And what is enthalpy of formation? Well, it is the heat of reaction for the formation of 1 mole of compound from its elements in their most stable form, right? And so what do we mean by that? What's considered the formation of water, right? We have H2, excuse me, not H2. Let's start from the back. We have H2O. For it to be a heat of formation, we want to know what is the delta H of reaction here when I'm forming 1 mole. So I have to have 1 mole, and we'll say this is liquid water, right? 1 mole of liquid water, or gas. Let's go with gas. I like gas better. From what? From its elements. That means it has to be O and H. Can't be anything else. In their stable form. Well, these guys are stable as diatomic. Plus gas, gas. There we go. We have to have this balance. That requires a 1/2 here. Remember, I have to keep this as a 1 or else it's not a standard heat of formation. So that means I need a 1/2 coefficient here. It's kind of weird for us. Stoichiometry, we rarely use 1/2, but for thermodynamics, we use them quite often. So this would be my heat of formation, right? This would be a heat of formation number. And what does this little thing here mean? What does this prime mean? It means standard state. And so what is our standard conditions? Not standard state, standard conditions. What are standard conditions for this 1 atmosphere and 25 degrees C, which is also known as 298 K? Good. So we learned about heat of formation, and then we talked a little bit about, hey, how you can calculate delta H of reaction, standard delta H of reaction from my standard heats of formation. Why? Because there's this great little table. Yoink. I have these tables, and this is a small one, but there are big ones that you can use where someone's already done all the work of determining these standard heats of formation, and now all we have to do is apply it. And how is it that we can apply this? Let's go down here where we have more space. Zoink. My standard heat of reaction for a reaction is equal to M, or some other unknown variable, let me put it that way, standard heat of formation for my products, minus N, standard heat of formation of my reactants. Got it? So let's take a different case here. Let's say I have CO, 2 COs, gas, plus O2 gas, yielding 2 CO2 gas. And we want to know the delta H of reaction, the standard delta H of reaction here. How do we do it? Well, my delta H of reaction standard is equal to my coefficient. Oh, excuse me, I should remind everyone, M and N come from my coefficients, in my balanced equation. That's how I figure out what M and N are. Good. So here's my product. Yoink, yoink, yoink. So I'm going to take my standard heat of formation of CO2 gas, and I take that coefficient and I place it in front here. Good. Then I'm going to subtract my reactants, and I have 2 times standard heat of formation of CO gas plus 1 times the standard heat of formation of my oxygen gas. And that's what we do. And when we look up my oxygen gas, we'd see that that's a 0. That most of my elements in their stable, most of my elements are 0. You might want to check because sometimes if they're in a different state, you won't have a 0, but most of them are 0. Got it? Excellent. So where do we go from here? We do one more trick here. We can now calculate a standard heat of formation if we're given the standard heat of reaction. So consider the decomposition of 1 mole of solid calcium carbonate. CaCO3, solid. It's going to decompose. Hey, this is a polyatomic ionic compound. When they decompose, they form what? Well, a metal oxide and a non-metal oxide. My metal oxides are solid. My non-metal oxides are usually, not always, but usually gases. So this is what we'd form. And it's a 1, 1, 1. If we wrote our equation for delta H reaction, we'd say this is equal to 1 times the delta H of formation of CaO, solid, plus 1 times the delta H formation of CO2, gas, minus 1 times the delta H formation of calcium carbonate, solid. But what makes this different is they're giving me this, yoink. So I know this is 178 kilojoules, and this is per mole, right? Per mole. And that's equal to what? Well, we want to know this. This is what we're after. So that means I look to my table, and I want to write down my standard heat of formation of calcium carbonate. Where is my calcium carbonate? Calcium, not calcium carbonate, calcium oxide, negative 635.5. Woo! Negative 635.5 kilojoules, and that's per mole of calcium, calcium oxide, plus my, oops, too soon for that other bracket, yoink, plus what? Right here, heat of formation of my carbon dioxide. Heat of formation of carbon dioxide, magic, woo! Carbon dioxide, negative 393.5. Negative 393. Wow, that's pretty. Negative, like the last woman I dated. Yikes. Negative 393.5 kilojoules per mole. Zoink. Minus my delta H formation of calcium carbonate, which we're trying to find. So all we do is use our magical math skills, and I have what? 635.5 plus 393.5, and that's equal to, not that, 635.5 plus 393.5. Good. And I have 178 is equal to a negative 1029 minus delta H formation of my calcium carbonate. And so what is my delta H formation of calcium carbonate equal then? Okay, I do some magic. I have to add that over there. So plus 178, good. Woohoo! Negative 1207 kilojoules per mole of calcium carbonate. There we go. Got it? And let's just see for the heck of it how close we were. Hey, look at this. They actually have it here, and man, we are close. Woo! Yay, hey. Great. All right, you guys try the last one, and we are done. Ooh, this one looks scary. It has a lot of stuff here. So here's my delta H. So my delta H reaction, and let's assume this is, they don't say anything, so let's assume that this is at standard conditions. So at standard conditions is equal to, let's write my equation. Well, my products 6 times my delta H formation of N2 gas plus 12 times the delta H formation of my carbon dioxide gas plus 10 times the delta H formation of my H2O, and be careful here, liquid, plus O2, okay, delta H formation of O2 minus 4 times delta H formation of my C3H5N3O9 liquid. Egads. And we want to find out this number. So all we have to do is start throwing in numbers. 6165.6 kilojoules is equal to 6 times delta H formation of nitrogen. I look back here. I don't see anything on nitrogen, right? No, so what are we going to assume? We're going to assume that it is 0 because it is a element. So this is 6 times 0 plus 12 times for my carbon dioxide gas. I think it's 393.5 kilojoules per mole. Let's see if I'm right on that. Carbon dioxide gas, no, 393.5. Hey, my memory is not failing me yet. Plus 10 times my delta H of formation of water liquid. Where's liquid water? Well, water. Here's water. Do as you oughta, add acid to water, right? Okay, negative 285.8. Negative 285.8 kilojoules per mole plus what? O2, but we know that's going to be a 0 minus 4 times my delta H formation of what I am trying to find, right? C3H5N3O9. Got it? So let's solve for this. Here we go. Are you ready? I need more space. Here we go. I think I can handle this. So I have a negative 6165.6 is equal to 12 times 393.5 negative. Oops, made a mistake already. 12 times 393.5 negative, and that's going to be a negative 4722 plus negative 2858. I can multiply 10 times that just by doing that. Woohoo! I like it when I can do that. Kilojoules per mole, right? Plus 0 minus 4 times my delta H of formation. Good. So I'm going to have to sum these up and add it to this side, and let's see what we get. All right. Negative 4722 plus a negative 2858. Okay. So I have a negative 6165.6 is equal to a negative 7580 minus 4 times delta H of formation. So I'm going to add the 7580 to both sides, negative plus 6165.6. 7580 minus 6165.6. I get a 1414.4 is equal to a negative 4 times my delta H of formation. Let's make sure that's right. Does that look right? Looks pretty right to me. 7580 minus 6165.6. C. Good. So then I divide both sides by 4, and I get an answer of my delta H of formation for C3H5N3O9 liquid is equal to a negative 354 kilojoules per mole. Got it? I hope you got the same answer as I did, because if you did and I did, we must both be right. If not, we're both wrong, and boy, we're in for a world of hurt. All right, folks, that will do it. That takes care of Thermochem. Good luck on the quiz and test, and see me if you have any questions. Enjoy the day. Ciao.